class, this is section 4.2. We are going to talk about area and how it relates to an integral. So, make sure you take notes on this video and put me on pause whenever you need more time to write things down. So what we are going to be doing is called finding Riemann sums. By inscribing and circumscribing rectangles. We will look at left Riemann sums, which I will abbreviate that left Riemann sum. We will look at right Riemann sum, which I will call RRS, and then we will look at midpoint Riemann sums. Which of course I will call MRS. Okay, so I'm going to teach you how to do this by just using an example and just working with it, okay? So we are going to graph y equals negative x squared plus 5. So hopefully everybody knows what that looks like without pulling out your calculator. It is a downward parabola shifted up 5. It's going to hit the axis at plus or minus square root of 5. So it looks like this. We are going to look at the interval between 0 and 2. And we are going to use 4 rectangles. And the first one that we will look at, we will inscribe the rectangles. So if I'm looking between 0 and 2, here's 0, here's 2, we're looking at this region right here. So if I want to put 4 rectangles in there, then the width of my rectangles can be determined by using b minus a over n. So in our case, 2 minus 0 over 4 gives us a width of our rectangles to be 1/2. So at 1/2, I'm going to put a mark. Then I have a mark at 1, 3/2, and 2. So each one of my rectangles has a width of 1/2. And then I want to draw my rectangles in there. Notice I drew my line straight up. And if I am going to use left Riemann sum, that means I want the left side of the rectangle to hit the curve. So that is what left Riemann sums looks like in this case. Because the left top corner of my rectangle is the point on the curve. So what are those coordinate points? Well, the first rectangle is made with x as my coordinate, x equals 0 as my coordinate. So if I plug 0 into my function, and you can make a chart if you want to, But if I plug 0 in, I am going to get the coordinate of 5. For the next point, if I plug a half in for my next coordinate, then I have y equals a half squared plus 5. So that is negative 1/4 plus 5, which is 20 over 4. So I have 19/4 as my next coordinate. So at a half, I have the coordinate 19/4. For my next coordinate, if I plug 1 into my equation, I will get 5 minus 1, which is 4. So my next coordinate is 1, 4. And then the last one that I have to do for left Riemann sum is to plug in 3 halves. So I'm going to plug 3 halves in, square it, and add 5. So I will get negative 9/4 plus 5, which gives me negative 9/4 plus 20/4. And 20 minus 9 is 11/4. So that will be my last coordinate. Okay, so I had to find the height of my rectangle so that I can find the area. So what I like to do is just put area 1, area 2, area 3, area 4, and just write out the area of the rectangles. Hopefully everybody knows that the area of a rectangle is the base times the height of the rectangle. So if I'm looking at this first one, the base is a half, and the height of it is 5. So I have a half times 5. The next one will be a half times 19/4. The third one will be a half times 4. And then the last one will be a half times 11/4. And then from here, I am just number crunching. So I have 5 halves, 19/8, 2, and 11/8. So what I like to do is change these all into 8s and add them up. So if I change 5 halves into 8s, I get 28s. I already have 19/8. And if I change 2 into 8s, I get 16. And then the last one is already in terms of 8s. So then I'm just going to add up my numerators and put them over 8. So I have 20 plus 19 plus 16 plus 11 will give me 66/8, which of course I can simplify to be 33/4. So my left Riemann sum is going to be 33/4. Now, I am going to draw my right Riemann sum on the same graph, just so that you can see the difference in my rectangles. And another thing I'd like to talk about here with my left Riemann sum is if I'm trying to find the area underneath the curve between 0 and 2, and I have used these rectangles, it looks like, because my rectangles hang over top of the curve, that area is really going to be a higher estimation than what the real area is. Now there is this little bit of extra space here, but then we have extra in each rectangle. If I use my right Riemann sum, which I will draw this in black, from 0 to 2, I want the right-hand corner of the rectangle to hit the curve. So in this case, the first rectangle that I'm going to look at is this rectangle right here. My second one looks like this. Then my third one will look like this. And then my fourth one, which I'm going to have to use the coordinate of 2, which is here, looks like this. So if you compare the rectangles, the right Riemann sum, drawn in black, is underneath the curve. So I have extra space in between the rectangle and the curve, and quite a bit of extra space that has not been included if I am talking about the area underneath the curve. Now let's do the areas and compare the different ones. So I have area 1, area 2, area 3, and area 4. Again, all of my widths are a half, but my heights are going to be a little bit different than they were last time. Not a lot different, just a little different. This first rectangle, the point that I'm going to use is the right-hand corner of my rectangle. Well, the y-coordinate is 19/4. So the height of my first rectangle is 19/4. The height of my second rectangle is 4, and then 11/4, and then I'm going to have to use this coordinate here for my last rectangle. So if I plug 2 in, I have a coordinate of 1. So that last height is going to be 1. So 19/4, 4, 11/4, and then the height of 1. So this is 19/8. This is going to be 4 over 2, which we know is 16/8. We have 11/8. And then we have a half, which we have to write in terms of 8. So we will put 4/8. When I sum these up, I am going to get a different area. I have 19 plus 16 plus 11 plus 4 to give me 58, which when you simplify that is 25/4. Now, this is my right Riemann sum compared to the answer that I got when I did the left Riemann sum. Obviously, it is lower. That is because of the curve I am looking at. It will not always work that way. If I am looking at a function that is concave up, and I look at my rectangles, the right Riemann sum would be larger because it would be hanging on the outside, where the left Riemann sum would be underneath. So it depends on your curve whether the left Riemann sum will be larger than the right Riemann sum. So make sure you pay attention to that. I am not going to work the midpoint in this case, but we are just going to look at it. If we were going to do the midpoint rectangles, which I will draw in green, the midpoint would be the x-coordinate right here. And the midpoint rectangle would actually split left and right. And you would just use the midpoint of the rectangles and then find the area that way. Okay, so why are we doing all of this? The area under the curve of any function is going to be the integral of that function. That is the application of integration, which we will be talking a great deal about. So for now, I just want you to know how to do left and right Riemann sums. You may have to do more rectangles or fewer rectangles. The more rectangles that you put underneath the curve, the closer your approximation is going to be. Okay, thank you. We'll see you in class tomorrow.